All right, so we just found the V 50%, and so now we want to find the pH at 50% of the equivalence point. So we found the V 50% to be 11.25 milliliters. Well, unfortunately, we don't have a measurement at 11.25 milliliters for the pH. So what we need to do is we need to take some of these data points and fit a line to them, and then use the equation of that line to determine what the pH would have been at 11.25. Okay? So we want to use as many of these data points in here. We don't want to use the points at the tail or any of these points up where it's starting to curve. We want to use the ones where we just kind of say, okay, those look fairly linear. Okay? So I'm going to guess it's probably, I don't know, 3 mils to 16 mils. Okay? So the way we do this is we click on our chart. Click on chart, we go to source data. We go to series. We already have a series on here. I can give it a name. That's our pH curve. So we want to add another series. I'll just call that lower curve. So for the x values, we want to use the milliliters from 3 to 16. And for the y values, we want to use the same range. So we'll go from 3.68 to 4.88. And we just click OK. And we can see all it did was duplicated those points onto this same graph. Alright? So now what we want to do is fit a line to these data points. So it's really easy. Just go to chart, add trend line. If you have Excel 2007 or 2008, I think you just right click on the series and that dialog will come up, add trend line. Okay, so we want to just curve fit it to this lower curve. We want to do a linear regression. Click on options. We want to display the r squared value, display the equation on the chart, and display the r squared value. Okay, so this black line is just the curve, and the equation here is the equation that fits this line with the r squared value of 0.995. R squared values are going to range from 0 to 1. The closer it is to 1, the better it fits those points. This would not tell us that we have a 0.5% error in our values. This is not an indication of error. This is just a measurement of the goodness of the fit. Okay? So then what we want to do up here is we want to say pH 50%. So there's two ways that we could enter an equation here, or enter the equation. We could either enter these numbers as they appear here, or we could select the values here. I'm going to show you the way where you actually build the equation. I like that a lot better because it keeps the full number of digits that Excel will store instead of just rounding it to 0.0884. So we just press equals slope. So this is calling the function slope, and its syntax is known y's comma known x's. So you want to select your known y's. So I did 3 to 16, comma, and then your known x's. Okay, and then we close the parentheses. And we're going to multiply that by our x value, which is 11.25. We want to add on the intercept, so we just go intercept. So this is calling the function intercept, and it has the same syntax, known y's comma known x's. So we go known y's comma known x's. And there you go, 4.47. So that's pretty good. So what that tells us then, when we look at that, is if we look here, we know that Ka equals the H plus concentration at half the equivalence point. So the Ka is going to be 10 to the power of the minus pH 50%. So what we have found is the pH 50%, which is equal to the pKa of our acid. Okay, so all we need to do now, move this out of the way here a little bit. Ka, so that's equal to 10 to the power of minus our pH 50%. And there you go, 3.3794 times 10 to the minus fifth. So we found our pH 50%, and our ultimate goal was to find our Ka. And that's really actually pretty close. I think the true value is 4.75, but don't quote me on that. All right, so good luck.